Hi, everyone. Good evening, and welcome to day 3 of our Explore with Azure Bootcamp. We hope that you all have learned and gained a lot of experience in past 2 days. So this being the final chapter of your bootcamp, we hope that you are able to learn more. And there is this is again an interactive session on Azure Machine Learning with our speaker, Mr. Prashant. Who is very well accomplished and who would be taking you through the session today. Request you to put your best foot forward, try to learn more, and we look forward to your contribution, your interaction. Please post your questions in the chat. We would be addressing all the questions at the end of the session, or even in the between. Also, we can do that. And thank you very much. And I'm now not handing over the virtual stage to Prashant. Thank you.
Thank you so much, Anamika, for your introduction. Hello, everyone. I hope every one of you is doing fine. It is really a nice opportunity for me also to be addressing you all on the Azure AI. Today I'll be talking about Azure and a bit of my experience working with Azure, and specifically about, with Azure AI and Azure Machine Learning, and what all services are there which we can leverage from Azure for our developer workflows and also for our needs. So first of all, a very brief introduction about myself. I'm working with the NIC, and I have about 10 years professional experience. I have experience working with the private cloud, this DevOps, Kubernetes, containers. These set of technologies. For last 2 years, we have also embarked onto this public cloud journey. So we have had experience working with Google Cloud and also Microsoft Azure. During my journey with cloud, I also worked through certain certifications. I have accomplished certifications like Azure Administrator Certification and also Azure Developer Associate, besides the fundamental ones. I hope that today we would have a fruitful discussion on the Azure AI related services. And I invite you all to post your questions during the session so that I can probably better gauge at the kind of expectations you have and if we are going on the right track. As I was informed that I have to keep it at the introductory level. I'll try and present the concepts which are required for anybody who's probably not having a background in machine learning or AI or even Azure. So I hope that you all would be able to follow along. I'm sharing my screen with all of you. Just a second. I hope all of you can see my screen. Uh, it would be good if somebody confirmed. Yeah, thank you. Right. To begin with, we would be starting with the definition of AI. I think as part of your course curriculum, maybe most of you would have already heard about what is AI and how it is different from the traditional programming. Typically, in case of traditional programming, we write all the logic, wherein we tell that upon what condition, what processing we have to do. Whereas AI is more about where the software or the program that we are writing, it is capable of discovering the solution on its own, and it is driven by data. Basically, if we look at the slide, it says that any software that imitates human capabilities could belong to the category of AI. For example, how do humans act? Basically, we act based upon whatever data we have and what all kind of experience we have had with a given scenario in the past. So AI is similar. The efficacy of an AI algorithm or an AI solution greatly depends on the data. So the more data we feed into it, the more training we have given to our model, the better would be our results. Also, AI is leveraged to solve another class of problems that is called anomaly detection, where we can also discover anything which is abnormal. For example, like I said that I've been working with data center and cloud related services. So there typically are scenarios where there is uneven spike in the traffic or something that we had not envisaged, and it suddenly happened. So those kind of things, probably AI can look at the traffic patterns and let us know in advance that something is wrong with the traffic pattern, uh, and it is different from what it used to be. Also, AI has a different stream where uh, we can also interpret visual input. So from visual input, we can say that image recognition, face recognition, these kind of technologies or I mean applications of AI you must already be familiar with. For example, when you go to Facebook and you try to upload a photo, there is automatically a suggestion that where you can tag one of your friends. So it is AI basically behind the scenes where it is able to identify like which of your friend is there in the picture. Similarly, there is one more category or field of AI that is around language. So basically, that stream we refer to as natural language processing. So basically, text recognition, any text recognition or any speech recognition generally falls into this category. And also, I think all of us must be using web apps and web services. And on any website these days, especially the ones where there is some shopping involved or there is some customer service involved, you must have seen there are chatbots. So basically, chatbots are an application of conversational AI, and they are also very prevalent these days. So basically, this is a broad overview of AI and streams of AI, where we can make decisions, we can do anomaly detection. Then there is this specific field where we can have this image recognition. So these are broad streams. Now, going forward, these are typical kind of AI workloads. So they basically represent the typical scenarios where we leverage AI. For example, machine learning. So machine learning, where we typically leverage machine learning for making predictions based upon past data. For example, based upon the patterns, for example, the temperature patterns or the wind patterns. The atmospheric departments typically make predictions how the weather is going to be. So that is one example of making a prediction based upon the past patterns. So that is what machine learning is all about. Secondly, anomaly detection, like I told you, that if we are to detect anything which is anomalous and which is something which happened out of context, for that also we can leverage AI. Computer vision, like I told you, for example, the image tagging option that we have in Facebook and other social media platforms. So that is around computer vision, and also NLP and conversational AI. So basically, these are the different kind of workloads, or we could say that different application areas of AI which are prevalent. So, what is the role of Azure basically when we talk about AI, and how does Azure add to what we do with respect to AI? So, in any AI solution, there is lots of data, and we need to process that data. We need to store that data, and we also need to create models. So, models are basically algorithms which are trained upon data. So Azure basically helps in all these. So like we can see in the slide, for processing a large amount of data, we need a scalable platform. So basically, these public cloud providers do have hyperscale platforms, so they can scale beyond anything. So we can run our Azure models, we can train them on cloud, and we can get charged only for the amount we use. So for example, if we had to train the same models in our premises or in our local data center, then we had to procure all that upfront. So all those advantages are also available as for other normal cloud services. They are similarly available for the AI. So like I said that for this we typically need data storage, because you might be handling data which is very large. So it can be petabytes of data or maybe terabytes of data. So you need some platform where you can reliably store data at a scale, and that is also capable of giving you good performance. So Azure provides lots of data storage options. It has SQL options, no SQL options, besides other object storage options. So that is one part of it when it comes to the data storage and retrieval. Besides, you also need compute, because all the training and all the processing has to happen on some compute. So that is also one aspect that we can leverage from Azure. Besides, it also has certain services, certain custom services that we can directly leverage. So we need not develop models from the scratch. Instead, we can leverage pre-trained models or the custom services which are already there on the Azure, and we can then feed in our data to make predictions, or whatever stream of AI we want to make use of. So basically, the Azure services are classified into three categories, as we can see. One is the Azure Machine Learning, then we have cognitive services, and we have Azure Bot Service. So machine learning basically refers to the platform that Azure provides, where we can train models, we can deploy models, and we can also manage the models. So models are, in the AI parlance, as we know that we create models first, and then we leverage those models to make the predictions. Secondly, it also provides a lot of cognitive services. So cognitive services we will see later. Also, we have this bot service, like we said, that for conversational AI and also for creating chatbots, we can leverage this Azure bot service. Moving forward, just a very brief example of machine learning. So, like I said, that in machine learning, we let the program infer from the data set that how to come to the solution, like we said. So, over here, for example, we are trying to create a predictive model. So we have provided various flowers to this. For example, there are multiple flowers that, and we have done the labeling also. That this particular flower is, for example, Bellis perennis. This one is Rosa multiflora, and then this one is Tulipa. So we have given certain inputs or labeled inputs to this algorithm, and then basically this process is called as training, where we are providing the labeled input. So we are telling the algorithm that, look, if you're getting this flower, then this is its name. If you're getting this flower, this is its name. So when we next time provide a flower and without any labels, then the algorithm would be able to identify to which class does this flower belong. So that is the whole idea behind ML. If we go to the next slide and try to understand how it would work in this scenario. So like a team of botanists and data scientists would collect samples of wildflowers, and then they will label the samples with the correct species. So all the samples would be labeled by the existing knowledge that botanists have. And next, what they would do, they would process it through the algorithm to find the relationships between the samples and the labeled species. Once this gets encapsulated in a model, then whenever any new species is found out, we simply have to provide that to the model, and it would be able to uh, identify the correct label. So we don't need to label it afterwards. Uh, Basically, there are three kinds of approaches. So fundamentally, I'm not sure how many of you have actually taken the ML course, but uh, the ML algorithms are typically classified into supervised learning, semi-supervised learning, and also unsupervised learning. So basically, in supervised learning, we already provide labels during training, and then the algorithm is made to determine later on from the earlier data set. So in case of unsupervised, it is up to the algorithm itself to find patterns in the data. So clustering typically falls into that category. So also here, as we can see, in supervised learning, we have two kind of options. For example, one is regression and the other one is classification. So in regression, we typically predict some value. So for example, let's say that in this slide, we are talking about how the rentals of the bike will be affected by the temperature. So as we can see, when the temperature is 56, so the price is somewhere around 115. So let's say temperatures are in the Fahrenheit scale. When it is 61, it is 126. So likewise, we already have rentals from the past and how they were affected by the temperature. So based on this, we try to plot these values. Like on the right side, we can see that we have plotted these values. So on x-axis, we have the temperature, and on the y-axis, the rentals for the bicycle. And then we try to come up with a function which can accurately describe the relationship between the two, that is the rentals and the temperature. So as we can see, a model that closely fits this is a straight line. So over here we have figured out what the slope would be and what would be the intercept. So now we have a model that says fx equal to 35 plus 1.5 into x. Also, when we have data, we typically divide it into two categories. One is the training set and other is the validation set. So we use validation set to actually verify our algorithm or verify our model, whether it is correct, it is predicting the correct values. So whatever model we have developed, is it actually valid for the already available data set which we have partitioned. So we have only used one part of the data to train the model, and some of the data points we have kept just for the validating it. So if we put in the values for the validation set, then we get approximately correct values for y. So over here, we are not classifying anything. We are just trying to predict a real value. So these class of algorithms or these class of problems typically fall into regression. So next up is classification. In classification, we are more into saying whether something comes into a given category or not. For example, we all are used to using emails. So spam filter is an example of a classification, right? Where given an email, if we have to figure out whether it is a spam or not a spam, then we are classifying it. So it is either yes or no. So yes or no problems typically fall into this classification. Next up is clustering. So it is an example of unsupervised learning algorithm where we don't give any labels and we let the AI algorithm to find patterns into the data. So over here, as we can see, it is trying to figure out neighbors or data which are into the same categories. So over here, the data typically get partitioned into multiple classes depending upon their proximity. So now we are going to talk about what is Azure Machine Learning. Using Azure Machine Learning, we can create workspaces, and in workspaces we can set up our AI platform on which we want to do, or where we want to train our models and run our pipelines. Generally, we have a subscription in Azure, and within that subscription we typically create workspace. So workspace basically has your compute endpoints, your data sets, and whatever models we are using, any services that we have exposed. So those things actually comprise our workspace. Now comes we just would like to briefly touch upon what is automated machine learning. Basically, like we broadly understood, machine learning is about getting data and then kind of cleaning it and sort of building our models and then training our models and then using those models to do the predictions. So it has multiple aspects, and automated machine learning helps us with some or most of those steps. So as we can see, basically it takes the hard work out of machine learning. Over here, we just supply the data and desired model type and let Azure ML find the best model for us. So even the model discovery becomes easy for us. Next, we have this Azure Machine Learning Designer. Over here, we can create pipelines. So basically, pipeline is something where we have multiple stages. So we can leverage this visual designer to create pipelines. So this greatly simplifies our task. We are not going into much detail of this. It's just to give you an idea about such a service exists, and we can leverage to create our ML pipelines. So next up, we are going to discuss about the vision services which are there in Azure, and what all are the vision related services that we can have. So basically, one category would be image classification. So image classification is about identifying an image. So over here, for example, we can figure out that okay, there is a taxi on this. So this is classifying the image. So given an image, if we are able to figure out to which category it belongs to, or what that image is, that belongs to this image classification category. Object detection is about given multiple objects in an image, we are able to figure out or classify uh, different objects. So over here, as we can see, we have been correctly able to figure out there is a bus, there is a car, there is a cyclist. Next up is semantic segmentation. So basically, over here, since as we can see that the color of the so different objects are colored differently. So I mean, it is something which is done over and above. So once the objects are detected or they are classified, then the solution further imposes certain pixels on it. So for example, it has colored all the cyclists into green, and all the cars into blue, and all the buses into red. So this is semantic segmentation, right? Next up is image analysis. So image analysis is something which like we humans do. For example, if we saw in this image, we would be saying that okay, there is a person with a dog on the street. So this is something that an AI system can do, where it can leverage machine learning models with image analysis techniques to extract information. So like I told earlier, with the example of tagging feature on certain social media platform. So that could be one example, though that applies to image classification also. And next up is face detection, analysis, and recognition. So these technologies are also quite prevalent these days, whether into biometric systems or even in the phones. So we all must be using phones where some of them support this face lock technique. So all these leverage such class of algorithms, that is face detection, analysis, and recognition. Next up is optical character recognition. So here we are able to extract text from an image. So this is what OCR is about. So even Google provides these options now into Android phones, where we can extract text directly from the image. So that is one application of this. So coming to Azure, so basically we were looking at the broad areas of computer vision which are there, and now we are trying to map the corresponding services which are there into Azure for each of those areas. So like we can see, computer vision we can leverage to analyze images, videos, and we can extract descriptions, tags, objects, and text. So that is what computer vision service can be leveraged for. Custom vision is something that if you don't want to use the existing models, and we want to train some custom model for image classification and object detection using our own images, because any big hyperscaler already has large data set of images. So they have very fine tuned models. So for most purposes they might suffice, but if still we want that, okay, I want to have a custom mechanism or a custom model, then you can leverage this custom vision service from Azure. We also have this face service. This we can leverage to build face detection and facial recognition solutions. We also have a form recognizer service. For example, if you scanned a form and you directly want to extract the fields, it can greatly help to meet that objective. So form recognizer is leveraged for exactly that. Now we discussed about basic ML and how ML works, and we also talked a bit about this recognition, image recognition, and related services in Azure. Next, we are moving towards this natural language processing. So, natural language processing is all about text and language. So, over here, as we can see, it relates to text analysis and entity recognition. It also relates to sentiment analysis. So, sentiment analysis is like if somebody has commented on your pic and you want an AI system to automatically figure out whether that comment is a positive one or a negative one. So, there this can help. Besides speech recognition and synthesis, that is where also NLP comes into picture, since it requires understanding a language. Then there is machine translation. We are already aware about services like Google Translate and related ones. They basically employ this class of AI. And we can also do semantic language modeling, that we will see in bit more detail going forward. So, like I said earlier also, that we had three class of services where we talked about ML, then there is Azure Cognitive Services, and then we also have this Azure Bot Service. So, basically, Azure Cognitive Services relate to the NLP related applications of AI. So, as we can see for text analytics, we can do language detection, key phrase extraction, entity detection, sentiment analysis. For speech, we can convert text to speech, and then we can also convert speech to text, and then we can do translation of speech also. With the translator text, we can translate text. So there is speech translation, we also have text translation, and then there is language understanding. So we can also do custom language modeling, because a phrase or a verb can a phrase or a sentence can be written in multiple ways. So over there, this language understanding can greatly help. So, for example, this is text analytics. Given a sentence like "I had a wonderful vacation in France," this is the analysis uh, which has been provided by the corresponding service. It is telling us that the predominant language is English over here, and it is giving the sentiment to be positive. Like we can see the use of words "wonderful." The key phrases that it has extracted is "wonderful vacation," and the entities that it talks about is France. Next up is speech recognition and synthesis. Like we said, that speech to text and text to speech capabilities is this application area, and we can leverage corresponding Azure services to build solutions where we have these requirements. And then there is this translator text service and a translator speech service. For example, bonjour has been translated to hello, or a speech or the audio hello has been translated to hola, and also in Chinese. These capabilities are also there. Next up is language understanding. Since a statement could be written in multiple ways, so basically the AI system should be capable to understand the true intent behind that statement, So, for example, in IoT applications, this can be leveraged. For example, as we can see, switch the light on. So, over here, we want to turn the light on. So as we can see that for an AI system to understand this, it should be able to figure out what is the entity and what exactly we intend to do. This is something that is so prevalent that most of us might already be very well aware of, the conversational AI, since chatbots are almost everywhere. So basically, we can create dialogues where we don't need anybody dedicated on a customer support to answer very basic queries or maybe routine queries. These agents are basically known as bots, and we can leverage them over multiple channels. They can be over web chat interfaces, or even over emails or the social media platform, or even through voice. And then there is also a Q&A maker service, where we can define a knowledge base of question and answer pairs, and then we can create a kind of FAQ by using built-in chit chat. So this we can use to consume. This can use the knowledge base from different client tabs to create that Q&A. So it can automatically create certain FAQs for our business or for our application, depending upon the various input sources. So this can also be very useful for certain scenarios. So the corresponding services that we can leverage to create these kind of applications. So basically, we have this Azure bot service, which is a cloud-based platform for developing and managing bots, and it is also integrated with language understanding and Q&A maker and other services. So the integration of different services greatly helps, because like we said earlier also about pipelines. So in pipelines, we can integrate multiple services to meet the desired objective. And we can also connect through multiple channels like email, web, or other interfaces. So we did a basic survey about the various services that Azure provides related to AI and the core category of services. But since AI is something which is the hot topic of the industry and academia alike at this moment, and everybody wants to talk about AI, but then there are also challenges and risks with AI. So any developer or any student, any researcher or any practitioner should also understand these aspects of AI, and they are equally relevant and important. So these are some of the challenges that are there. For example, there can be bias. So for example, whatever model we are creating, if we have the data can have bias, or our approach can have a bias. So we need to see that any bias does not creep in purely by the nature of the data that we are using to train our model. Secondly, errors may also cause harm. So AI systems are being leveraged everywhere, for example, into surgery and in autonomous vehicles. So what if the system fails and there is a big crash or a big accident? So errors can be very costly, not just from a financial perspective, but also from that of human lives. So that aspect we also need to consider. And so if we are designing systems for critical scenarios, then we need to see, or we need to validate things well before putting those things into production. Data can also be exposed. So there are certain data privacy guidelines. For example, GDPR is there. We also have our own data privacy framework coming up. So we also need to make sure that any secret data or any important data that need not be exposed should not get exposed. For example, through a medical diagnostic bot. So what if it is being trained using sensitive patient data, and it gets stored somewhere insecurely, and we are just feeling that okay, it's just bot data, and we need not store it, or we need not encrypt it that securely. So then again, there is a concern of data being exposed or stolen. Also, the same solution may not work for everyone, so our solutions have to be inclusive also. For example, when we are designing a system and we are not considering visually impaired users, or we are not having the accessibility considerations in our solution, so those aspects also need to be taken care for. So we need to make sure that whatever solutions we are developing, they are also inclusive in nature. And also, there has to be, for example, if we are building a system and we expect our users to trust it, so we need to make sure that whatever data set we are using or whatever models we are leveraging, they are actually trustworthy. So if somebody is leveraging some, for example, it is there in the slide, if some AI based financial tool is there and people are using it to make their investments, and it is not working on any any trustworthy data, then it can have very bad implications for those people. Similarly, there's also a concern of liability. For example, if something goes wrong, like we were talking about face service, so there is face recognition option. For example, if there is an innocent person who was not a convict, and if he gets convicted just because of an AI, then probably that is not something which is desirable. And in that case, who is liable for such mistakes? So these are some of the challenges and risks, and we cannot simply not think of these while building our solutions. And these are the things that should be taken care while leveraging or using AI. So this is basically a reiteration of what we discussed before, that a responsible AI system has to be fair, it should be reliable and safe. It should also guard users' privacy, and it also be secure. Besides, it should be inclusive. So this is something that is probably least thought of while building solutions. So this is something that we need to think about. Also, it should be transparent. So the more transparent a system is, for example, a lot of open source software is around. So if a system is transparent, then multiple people can assess it, test it, and also it will also increase their trust in such a system when it is transparent. And also, there is proper system accountability. So if something goes wrong, who should be held accountable? So these aspects also matter. We also have certain demos. So these demos are provided directly by Microsoft. So we have demos on computer vision. We also have a demo on language understanding. Then there is also a chatbot demo. So you can run through these demos, and this will enhance your understanding of AI. This would give you basically a demonstration where you can see that how AI works in practice. So I was told that I have to be, I mean, the audience is not somebody or who have great experience already with AI or ML. So I have tried to keep this session to an introductory one, and that's it from my side. I'm happy to take any questions or any doubts. Yeah, so there is a question from Lakshay Mundeja, and he is saying that machine learning is something which is cross-cutting and used behind all other types of AI. Yes, Lakshay, that is more or less true. It's like the underlying principle behind most of the AI, right? So machine learning is the underlying principle.
So, guys, in case you have any questions, please feel free to post it in the chat. We would be happy to take them now.
Yeah, and besides, just to add, I mean, if you want to learn more about fundamentals of Azure AI, then Microsoft Learn is a great resource that you can leverage. So it is entirely free, and you can get great content there. And there is also virtual training days, which you may have heard from Microsoft, that also can help you. So these are like 1 or 2 day I mean sessions which are around 1.5 hours or 2 hours, so that will also broaden your understanding about this.
I don't see some questions coming in. So that means that two things: either they have understood everything, or they have understood nothing. So, s- okay, mostly the same problem can be solved via reinforcement learning, machine learning, and deep learning. How to decide which one to pick?
Rajan, I think, well, then it is something that that is more into ML. So basically, over here we are limiting ourselves to discussing in terms of capabilities in Azure to solve ML-related problems. So that is something probably I would say a bit out of scope of what we are discussing here.
Okay, Shubham. So for the exam, you have a Discord link that I was sent to you on the email. Tomorrow we have a test. We have a quiz tomorrow. Come for the quiz first of all. In fact, everyone, please join the Discord for the quiz tomorrow. Any other question we have? All right, I don't see any questions coming. So, thank you so much, Prashant, for coming here today. It was a pleasure listening to you, and I really look forward to more sessions with you. Thank you very much, and whatever evening is left, enjoy that. Thank you.
Yeah, thank you so much, Anamika. It was really my pleasure to be able to present to all the students, and would be looking forward to such sessions in the future also.
Sure.
And all the best to all the students. And in case they have any queries, or maybe there is any cross-cutting themes that they would want to know more about, then they can also contact me. I would be happy to help.
Right. Thank you.